Dear students, today we are learning about SPR, which is called as surface plasmon resonance. This is a widely used technique in some of the optical biosensors. So, whichever sensor is using the principle of optical measurement, those sensors, most of the things will be using this technique called SPR. The reason for using SPR is more selectivity, sensitivity, and the speed of analysis also is high. Let's see what is SPR. First, let's see what is plasmon. So, plasmon is the oscillation of the material or the electrons on the surface of the metal when some energy is given to the metal ions. Metal ions in the sense, in this kind of sensor, a very thin layer of metal will be used, and on the surface of the metal there will be metal ions, and when they are excited with respect to some incident radiation, that is incident light, they start resonating. Resonating is nothing but movement of them in the back and forth reaction. You can see here, this is one metal ion, and you can see till what point it can get extended to, right? It will be moving back and forth. Even this metal ion in the forward direction, it will be moving. So resonance is nothing but at one particular frequency, these vibrations become maximum. So these plasmons usually happens on the surface of the metal. So it is called as surface plasmon. As they are continuously vibrating or resonating, it is called resonance. So this phenomena of electrons being vibrating happen on the surface. That's why it is called surface plasmon. And due to the vibration, there is a resonance created. That's why it's called surface plasmon resonance. And they interact with, so there should be incident radiation for them to interact, and they usually happen in the wave pattern. There is a wave pattern which happens between the metal and the dielectric post. So this is a diagrammatic representation of the SPR phenomena. Here you can see a source of light. The light source is usually a laser light, a monochromatic light. The reason why they are using a monochromatic light is there is no dispersion of radiations in any direction. And as they fall on the incident material, so this yellow color sheet is a metal that also is a gold coated in this example. So as they come and get incident on this metal, there will be vibration of the ions. And what happens is that there will be an angle of deflection of this material which will be detected by a photodetector. So any analyte or any enzyme or antibody, if you have to coat on them, they will be coated on the surface of this metal and the deflection angle will be noted. So this is a signal what you get from SPR. These detectors are usually connected to a data visualization point, that is a computer system where you can analyze what is a concentration of analyte that is being reacting. So initially there is no signal because there is no light that is being incident. So your resonance is 0 here. And as the light is incident, they start resonating and the graph keeps moving. And in case if there is a positive reaction, there will be a variation in the graph what we receive, and based on this phase shift, or you can say the deviation in the graph, the concentration of the analyte that is positive to the reaction can be noted. Beyond a certain point, there will be a dissociation. So next time, like when you are using the same sensor, the sensor should be dissociated with the contact material and can be reused. And during the regeneration, you can see that the signal comes back to the 0, telling that, okay, the sensor is ready for the next time of usage. As they are made up of pure metals, usually the sensor are not a one-time usage, they have to be reused. So that's why you need to look at the dissociation kinetics too. So association happen between the positive reaction, that is antibody when it senses a particular antigen, or an enzyme that is very specific to a substrate and they bind, there will be association reaction. So the dissociation energy of them. So when you have to separate those attached antigen and the antibody, there is some energy required to separate them too. That is called as a dissociation kinetics, and it falls down and finally the peaks receive comes to back to the zero, telling that sensor is ready for the next type of measurement. And this is a diagrammatic representation of again with the analyte, like how the SPR happens. So this plain polarized light, that is a monochromatic light, laser light, is being passed on the surface. The surface is made up of gold, and you can see there are antibodies that are coated on the surface. So now in this example, you can see that there is a one positive reaction here, and this is a negative reaction. There is no association of antibody with the antigen. And the third one, again, there is an association. So it is not 100% complete reaction or a 100% positive reaction. So the concentration of this analyte, that is the antigen that has come to bind to the antibodies, can be easily detected and accurately detected because of this technique. So now when you like the light is being incident on this gold material, there will be a vibration of this metal ions. Okay, so the this light is usually passed through a prism uh, for getting a better refraction, right? And from the surface, yes, the light that is being reflected are being detected by the optical detector. So in the point one, that is that the angle 1, you can see that it's a negative reaction, that is without the attachment of the antigen or antibody, you get a particular angle of deviation or deflection of the reflected light. Now when the reaction is positive, the reflected light, you can see the angle of deviation is separate for them. So measuring this angle of deviation, you can observe that what is the concentration of the analyte that is being uh, like attached to the antibody, or how much positive the reaction is. So you can see here two phase shift of reaction. So phase 1 shift and phase 2 shift, and you can see the resonance of the particles keep increasing as the reaction is positive. The materials that is being used for this kind of reactions are like uh, tungsten, right? Sometimes lead, cadmium, copper, silver, gold, all these are being used. But there is a difference between the metals that is being used here. If you use these, that is lead, mercury, cadmium, and all this, if you when you use the measurement is in the form of a UV radiation. The light what you get, that is a reflected light, will be in the UV range. So you will require a UV detector to detect the reflected light. But when you use these metals, that is copper, gold and silver, the reflected light is in the visible region. And especially where the most used metal are gold and silver, and platinum to some extent it is being used. Due to the cost of it manufacturing, the platinum is not being used much, whereas silver and gold are widely used, and the reflection capacity of these two metals are very, very good. So for those reasons, we are using the silver and gold. So widely used, most commonly, aluminum sometimes used based on the reflection capacity, but these two metals are in the pure form. Without any alloys, they are being used in the sensor making. And the thickness of this metal film when you make it is very, very less, that is in the range of 50 nanometer, very thin. Only then the metal ions will be in the resonance form when the instant light is being reflected on them. And sometimes we use the nanoparticles to use because the specificity or the amplification of the signal, all this will be in different fold, that is more fold when you are using a nanoparticle in that. So for that reason also you will use the nanoparticles for the synthesis. And sometimes the cost of the sensor can be reduced by using a nanoparticles based synthesis. But the purity of the particles and the material again to be taken into account when we are doing with the help of the nanotechnology. And the coating of the particles on the surface also should be uniform. If there is any gap or any, if there is an ununiform mixing and coating, then again the reflection will be different. So here SPR works again on a metal film. We call it as a metal film because the thickness of the metal what you're using is very, very thin. You have a prism, so the reflected light pass through them and the reflected light can be found out. The refractive index will differ based upon the medium what you're using. For different materials, the refractive index will be different. So it's like when you're using a prism, so it will intensify and you will get a better refractive index for finding it. So when you are like using antibody along with the some fluid, the density of the medium will differ, right? Usually antibodies will be coated in the form of a fluid form, so the medium density, air density, where it get reflected or refracted, so all this to be taken in account for the better accuracy of the machine, or else your sensor will have a lot of noises, that is unwanted signal pickup, which may lead into inaccurate measurements. So the medium density where your antibodies are coated or enzymes in that case, where it is coated along with what material is present, so all that the reflection and refraction will change based upon the density of the medium. So that has to be taken in account for the accurate measurement. Applications are many for this SPR technique. They are being used in dielectric, they are being used in many material making, adsorption process, but our interest here is on sensors, biosensors. So all the structures like DNA based sensor, virus based sensor, enzyme based sensor, all that can be coated on it. You can even have a lipid bilayer, like when you want to look at the target of certain antibodies, it can be even coated in the lipid layer and can be used. Sometimes non-specific reactions also can be studied using SPR technique. And tissue engineering is a wide field where you want to see the interaction of the new modified tissue, you can use the SPR technique. And this is in short of a glimpse of the entire class what we have done today. So I will repeat this SPR technique here. So there is a monochromatic light, thin film of metal. It may be a gold or it may be a silver or it may be platinum. So this blue uh, part is the metal film. Above that, you have a antibody coated on a particular medium. As I told you, the medium can be lipid layer, it can be a fluid, or it can be any viscous material, which the refraction or reflection to be noted. Right. So there is a layer here. On this, the antibodies will be coated, and if there is a positive reaction of the antigen with the antibody, the reflection of the light on the surface will differ. So in this reaction again, it is a 50% positive and 50% negative. So based on that, the first shift is for the negative reaction, that is without, when it is not being bound to the antibodies, you get a particular angle of reflection of this light and how much it is being captured. And when it is a positive reaction, the light incident and the reflected light will have a different angle. So this angle of deviation is being noted. It's called as a phase shift. And this phase shift is being checked for to know how much concentration of analyte is being reacting with it. So it's a very, very simple technique, but very effective technique. The principle of this SPR is to be clear for you to synthesize any sensors or being used in any other material formation too. So here you can see this is a flow channel, because usually when your analyte like which is having the antigen or the antibody or any enzymes or anything, so this will be coated in a kind of microfluidic channel. So when the blood, the samples will be usually blood or any tissue fluids or body fluids or even urine may be the sample. So if your analyte is present, it will be passed as a channel, and whichever is positive, it goes and binds to it. Whichever is negative is just flow through it. So from a particular amount of the sample, what you get, how much of concentration of the antigen, virus or antibodies or enzymes are present can be easily noticed, and you can find the resonance signal in the computer, and you can notice what is the concentration of the reaction being possible there. So the concentration of the antigens or antibodies which are present in the particular tissue sample or blood sample can be easily noticed with the SPR technique. I hope this class was useful to you and you could understand what is SPR technique. And with this, I will end my lecture. Thank you all.